Hello everybody, what we have for you today is how to prepare your NCS 5500 for the migration to Jericho 2, and we'll show you this just after the break. Hello Benoit, we are today in Paris, in Cisco office, just after Christmas. You are part of the CX organization, so maybe you can tell us a few words about you. Also about CX. What is exactly CX? I used to be part of AS, so I'm not sure what CX is now. So maybe you can tell us a few words about you and this org.
So CX is basically customer experience. We are trying to support our customer in their daily activities. So either choosing new hardware, inserting new hardware, validating new software or feature,
new
technologies, doing migration, doing architecture. We are helping in the whole life cycle of the customer.
So I know that you have been working on segment routing, EVPN, but also VXLAN also. But at the same time, you have been working for a big customer on this version 1 to version 2 replacement.
Correct.
Yeah, maybe you can tell us a few words about what exactly it consists and what you've done for this particular project.
So for this project, we have first configured the testbed representing the customer network. So we inserted NCS 5500 into real condition with the right scale, with the right traffic, and with the correct software. Then we simulated all this network around NCS with hundreds of routers. First, we made sure that the new software was not doing any regression in feature. Then we prepared a mode of operation, a map to upgrade to the new release and to the new hardware, Fab2 and Fan2.
Okay, so the map consists in detailing the different steps that an operator has to follow.
The idea is really to have a step-by-step guide, procedures that anyone can follow.
Maybe you can present the testbed and show us what is running at the moment.
Yep.
It's version 6.3.
So currently it's 6.3.15.
Okay.
We are running this on a 5508, 8 slot. Only one slot is used with a 36 by 100 line card with external TCAM. So it's a dash SE scale line card. We have Fabric version 1 and Fan version 1. We are running 6.3.15, correct. So we are verifying that the software is 6.3.15 indeed in XR mode and admin mode with the show command show install active summary. Then we are verifying Fpds. We verify that there is no ongoing or pending FPD upgrade on any of the components.
FPD is like firmware, right?
Yeah. So we have FPD on line card, on RP, on fabric card, and system controller. So regarding the testbed itself, we have only 3 nodes for the today demo. We have the NCS, the ASR9K, and NCS 5501-SE. We have a traffic generator based on T-Rex, the open source traffic generator made by Cisco. We have 3 types of flows going through the routers. We have L3 VPN, we have one pseudo wire, VPWS, and another VPWS going through RSVPT. We have RouteM injecting control plane and internet routing table V4 with some extension to prepare for the future scale in 2020-2021. So close to 1 million V4 routes and 250K for V6.
Okay.
So we have those sub-interface with L3 VPN and the 2 pseudo wire. A real simple topology just to demonstrate when a step is disruptive or not for the traffic itself. So basic pseudo wire, VPWS, going to the ASR9K, so going from NCS 55 and going to ASR9K. We have some traffic ongoing there. And the second VPWS is using a tunnel interface with RSVPT, forcing the traffic to go through NCS 5501. So here we can see the really simple RSVPT configuration with some explicit paths. So here, as you can see, on T-Rex, traffic is flowing. We can clear the counters and check that we are transmitting 40 gig of traffic and receiving 40 gig of traffic. There is no drop currently, and we will verify later on that this counter is staying to 0 during the upgrade procedure until the very last moment where the install activate command will reload the chassis.
So all the first steps are impactless, and just when the system restarts,
Correct.
you will lose packets.
Yep. We still advise to run those commands into a maintenance window, but they are not traffic impacting. We are just preparing the system up to the point we can just activate the new software and then reload the chassis. It takes about 20 minutes to do the install add step, where the system will just decompress all the file system on the drive. Then we have the install prepare step, which takes roughly 20 minutes as well. And then finally, the install activate command will reload the chassis, and it will take roughly 15 minutes to the chassis to be up and running with all the control plane and with convergence.
Okay. So you're going to reload the system, wait to get to a stable state, then you will shut it down to proceed with the replacement of the fabric and the fan trace.
Right. So the second part is really the hardware upgrade part. So we couldn't do it before because it needed some software level before swapping to the new hardware. So here we've chosen 663 to run the new component, and we will do this hardware upgrade in an offline methodology by powering off the chassis.
Could it be possible to perform the upgrade and when the system is rebooting to shut it down to replace the fabric? Or you prefer to wait the system to reboot completely and then to be shut down to proceed with the replacement?
Actually, we evaluated this solution as well, but we prefer to do it in 2 steps so that we will be able to run it into 2 separate maintenance windows, for instance. So here I'm backupping the running configuration in XR mode and admin mode.
The config goes to hard disk?
Correct. So we are synchronizing this to the hard disk part, which will not get erased during the upgrade procedure. So we verify as well with the command show install committed summary. We verify that the same level of software is committed. So here we are checking that FPD auto upgrade enable is indeed in the configuration in XR mode and admin mode. This will trigger the FPD upgrade automatically at the install activate step, just before reloading the chassis. This step is actually really convenient because we are upgrading the FPD, and as you may know, FPD to be activated needs a reload. So we are taking advantage of the install activate reload to at the same time activate the new FPD, the new firmware.
Okay.
One of the very important steps as well is to verify the MD5 of every and each RPM and ISO. So it takes some time, but actually it's very valuable to verify that you didn't do any miscopy initially.
So where did you find the hash to compare it to?
So you can find it on software.cisco.com. In the archive, you have a text file containing every MD5 of each file.
Okay.
So now we are ready. We will add the new software into the file system. So the command is install add source, then the folder where you placed all the RPM and the ISO, the mini ISO. Then on the single line, you can put all the RPM and the ISO file. You don't need to do it in multiple steps. You can do it all at once. So as you can see, you have all this long line of CLI, install, add, source, hard disk, and all the required packages. The installation will go and run in background. You can follow where is the install process with the show install request. So as you can see, the install add process is going on, and traffic is still going through with absolutely no drop. So the install add got through, it's finished, it's operation 16 as you can see. If we do a show install inactive summary, you can find all the packages you just have added to the system in 663 version. Then next step is to do install prepare ID with the very last IDs that have been used with the install add operation. So you can do all at once, install prepare and install activate. So as you can see, during the install prepare step, we still didn't lose a single packet. You can still follow up where is the installation process with show install request. So install prepare is now finished. Next step is to run install activate. Here we are using install activate no prompt. So the no prompt argument is deactivating the prompt, asking for your confirmation to reload the chassis. By doing so, we are triggering the FPD upgrade automatically. So here, in our case, we are upgrading FPD on RP, on line card. For a moment, traffic is still going through without any drop. It will start dropping actually when the chassis is reloading, finally.
And you say that part will take 15 minutes now?
Yep, 15 minutes to get the chassis up and running with all the control plane and its convergence. Okay. So on the console, you can follow the FPD upgrade. It takes some time, depending on the number of line cards you have in the chassis. All of this is happening in parallel. Doing a show hardware module FPD, you can see that some of the nodes need a reload to activate the new FPD version. You have the two columns running and programmed. Programmed will take over once the node has been reloaded. Okay, so now the chassis is reloading. As you can see, we start dropping the traffic, obviously. And from there, it will take roughly 15 minutes to get all the control plane up and running.
If I remember well, you're going to get the prompt quite fast, quite quickly.
Right.
Then, but it's going to take still time to have all the line cards, loading the software, turning all the ports up. Then your routing protocols will kick in and start learning routes, etc. So when you say 15 minutes, you count all this.
Everything, correct. So the console is quite verbose, so don't worry too much about all the messages which are displayed on the console. Just be patient.
What are you looking at to make sure it is ready? You type show specific show commands, or you wait for a specific log message?
So to check where we are at the boot up process, you can do some command like show platform, which is a good indicator if a node booting well. Then a good sign that all the control plane are converged is a show redundancy. It means that both RP are in sync, and usually redundancy happens after convergence of protocols like BGP, ISIS.
So all the routes should be learned, then synchronized between active and standby RP to be NSR ready, or
to be NSR ready. One note about that, as you could see, we run the migration process only from one RP. You don't have to take care about the secondary RP. It will take over the new software directly from the new RP, from the other RP.
Okay. Something also we could say is in your testbed, you are using the very first version of RP.
The one without the timing option.
Yeah, okay.
We verify now the activated software is indeed 663. The committed software is still 6315. So we'll go ahead and do install commit to have 663 to be the next software at the next reload. If you don't do that command, then the chassis will roll back automatically to 6315.
I've seen that a couple of times in the past. People thought, okay, I reloaded, it's fine, but until you type install commit, it's really not
it's
carved in stone. It's still, it could be a way to step back, actually. If something went wrong, you can just reload to get back to the firmware release. But if you don't do it purposefully, that the next reload could be a bad surprise, because
it's a command mistake, but actually it's a feature, and it should be used as a feature, not a
true.
Not a
you know what people say about this, but you call a feature. Okay, good. Okay. No, it's true. It's something I've seen multiple times in lab, but also in production, fortunately. So install commit. Don't forget it.
Don't forget install commit at the very end of the software upgrade.
Okay. So once we are here, what's the next step?
So here we are verifying all the control plane. Obviously, you will have prepared some bunch of show command to check all of your services. Either you are running L3 VPN, L2 VPN, some RSVP tunnel, some multicast. It's strongly advised to take a snapshot before the upgrade and after the upgrade, and then to do a comparison of both.
Compare the route, the number of routes and so on. Yeah.
Yep. So here in this demo, we have just a stretched list of show command, but we encourage everyone to increase this list with all their favorite show command. So we are waiting for redundancy to happen between both RP.
Something we could say is at that moment, even if only the active is running and the standby is not in sync, the service is
going through. It's
packets
up and
are
running.
Yeah, it's only that you are not ready to do a switch over between
Correct.
standby and active.
Yep.
So service at that moment is restored. If you go to the
we go to the T-Rex right now, and you see drop rate went back to 0. So service is okay. We are still waiting for NSR to be ready on secondary RP. It will take a bit of time.
Yeah, that will take a few minutes.
And here we go. We have this message. NSR ready.
So that is usually a very good indicator of we are good.
Right.
Upgrade is finished and we are back to normal state.
Yeah. At least every control plane have converged, and we are now ready on the chassis itself. We don't have any extra step to do apart from verifying the services.
Great. So I believe now we can go to the lab and perform the
hardware upgrade.
The next step, which will be replacing the hardware. So a quick refresher, I suppose many people should know, but if not, if you want to insert new Jericho 2 line cards, the one that are named NC57 something, you're going to need to have first a new fan tray and a new fabric type in your chassis. So what we call the version 2, the V2s.
Yeah.
So for this migration, you are completely shutting down the box, I believe?
So we are doing an offline migration. As you said, fabric and fan tray are going in pairs. So either you run V1 on both or V2 on both. And to do the upgrade, indeed, we are shutting down the whole chassis.
Okay. So in your case, you make it simple. You just shut down the box, remove everything, replace, and reinsert.
Exactly. So first we power down the chassis, removing the plug at the front of the chassis, depending if it's AC or DC. You have some other methodology. Then we go at the rear of the chassis. Everything is happening at the rear. You have the fan tray first, so 3 fan tray. You have 6 fabric cards and 2 fabric cards per fan tray. Fan tray are powered on by the fabric card itself. So yeah, we are unscrewing every fan tray, then removing all the fabric card as well.
One common question will be, can we do that in service? And I believe it is not officially supported.
By doing offline migration, you are covered by Cisco support. If you ever go to online migration, we cannot just assure anything.
Okay, clear.
The rear of the chassis is completely empty. Then we will insert the new fabric.
So now you have everything replaced. You will simply turn it on, right? You're gonna just...
Yep. So just bring the power back, and then we'll just have a look to the console itself to verify that the router is going up.
Okay. So what are the show commands you are using to verify the new components and the health of the system?
So with show platform, you can verify the fabric are indeed recognized by the system. So we have fabric card version 2 and fan tray version 2. Both modes are booting, XR mode and admin mode. So traffic is not restored yet. We are still dropping everything. So here in our demo, one fabric is taking a bit longer than the other to go active, in active state. So we will be able to use some other show command to monitor the state of the fabric. In admin mode, you can do show controller fabric plane all, and you can see that the plane on fabric 1 is still down. No packets are going through fabric 1. Then you have this message, plane 1 state change to up. By doing the same show command, you can see that the plane indeed is in up state. And after a few seconds, we will see that the statistics are getting increased on Fabric 1. And as you can see, the service is now restored and drop rate is back to 0. Okay, so that's it. We have our chassis in Fantray V2 and Fabric V2 ready for the 400 gig line card.
Thanks a lot for the demo. Thanks a lot for showing this in your lab. And we will see you in the next one. Bye.
Bye-bye.